Hello, I'm Ms. Michelle from Perquimans County Library. Thank you for joining us today. We're going to do a demonstration on how birds stay dry in water in the rain. And this comes from Kate the Chemist, the Big Book of Experiments by Dr. Kate Biberdorf. She's a science entertainer. You can find her videos on YouTube. She also writes chapter books for children, which we have that series in the library now, so you can check that out. And this book is also in the library, so you'll be able to check that out and see this experiment and also others that are a lot of fun. So what you'll need is crayons, a piece of paper, something to protect your surface with. She suggests a baking pan, and water with some food coloring. And also a spray bottle, because you're going to spray the water on your paper. So the first thing you do is draw yourself a little furry friend. I chose a penguin because I am not artistic, and I thought that he might be a little easier than some of them. So make sure you color him in completely, because that's important. And I'm just going to read the experiment. So it says, make sure you cover every part of your animal with a layer of crayon, but you want to leave the background empty, no crayons in the background. You fill your squirt bottle with water and put some food coloring in the water. And then you place the drawing on the surface that is protected. And then you use the squirt bottle to cover the entire page with paper. So and use the food coloring so you can really tell the difference on how it's going to react onto your paper as opposed to the colored parts of your bird friend. So the crayon is like the feathers of a bird, and it's going to repel the water, and then the rest of the paper kind of absorbs the water. So if you lift up your paper, the water on your furry friend should be repelling. You can see a little bit, hopefully, that it is running down the my little penguin, whereas the rest of my paper is just kind of soaking up the water. If you see it, it's beating up on the bird itself that I colored. She has some questions in here for you to think about. What does the crayon wax represent in this experiment? Well, in this case, it's going to represent the feathers of the bird. How do feathers repel the water? Well, I'm going to read you her description in just a moment. It is partly scientific and partly easy to understand, so I'll read it directly from the book. What would happen if you used markers instead of crayons? Do you think the experiment would still work? Well, in this case, depending on your marker, the type of marker, regular marker probably would not work the same because it is not wax. The wax of the crayon is what is important in this experiment. And what will happen if you melt the crayons and use paintbrushes to apply the wax to the drawing? In that case, you still have wax. It's in a different form, which would melt and become more of a liquid, but when it dried and hardened again, it would still do the same thing. It might even cover it more completely. So I'm going to read to you how it works. It says, many feathered animals like ducks and penguins have a gland that forms a special oil that keeps their bodies dry. The bird will find creative ways to whirl around in this oil until all of its feathers are completely coated. The oil has a very important physical property. It is a nonpolar molecule. This means that all of the electrons, which are negatively charged particles, are evenly distributed across the molecule. A nonpolar molecule does not want to be anywhere near a polar molecule, which would be a positively charged electron, such as water. The water is a polar molecule. In fact, the oil provides a protective layer over the feathers, repelling any rain or water that hits the bird. We can use crayons to replicate the nonpolar interactions between oil and water. Crayons are composed of wax, which is a nonpolar system with strong dispersion forces. That means it rejects it. When we covered our birds with the crayons, we added a protective layer of wax to the paper. This nonpolar properties of wax repel the polar properties of our blue water, just as feathers repel water or a raincoat shields us from the rain. Have you ever noticed how water beads up on your raincoat? We tend to shake the water off our raincoats in the same way that birds shake off the water of their feathers. It's neat, huh? So that is something simple that you can try at home. Like I said, you can check out Dr. Biberdorf's book from the library. It has a lot of, some are messier than others, but a lot of experiments that you can try at home. And thanks for joining us today.